All right, we are continuing with 7.4. So in the last video, we learned about factoring a trinomial with no leading coefficient. And that was from filling in the x factor, and then you take those numbers and you fill them in. There is a special case of trinomial that actually ends up becoming a binomial. And we call this special case the difference of squares. So the difference of squares is a binomial with terms that are both, zoom in here, perfect squares and subtracting. And in your general kind of rule here, we see that. So if A was a number and B was a number, so we might be talking about like, if we had like 5 squared minus 2 squared, which would really look like 25 minus 4. Actually, that was a bad example because we want to have a variable in here because 25 minus 4 can be solved for. So let me redo that example, and we're going to say x squared minus 2 squared. So if I had x squared minus 4, this would be a difference of squares. Or if I had, well, how about we just take a look at it, okay? And here is the shortcut for the difference of squares. So the difference of squares are nice as long as you can identify them, because there is a really nice shortcut, and that is whatever your value is being squared, so in this case it's a, and whatever your value is being squared, in this case it's b, and both of those are going to go here, and then one of my sets will be plus and one of my sets will be minus, and I'll show you kind of how that works with numbers and some of those things right now, but that's the shortcut. So let's take a look here at example A. And I think of these in one way. I'm going to show you couple different ways to think about them, but I always look and I say, okay, are there two terms? So that's the first thing I'm asking. I'm going to write some notes on the side here. Are there two terms? Okay, and then, so that's the first thing. The second thing is there a greatest common factor? If so, I need to factor it. My third thing, are they subtracting? Okay, so are there two terms? Yep. Is there a greatest common factor? If there is, I just need to factor it out. If not, then there's not. And then I want to see, are they subtracting? And are they perfect squares? These 3 and 4 kind of go together. Ooh, vig. Are they both perfect squares? Again, if so, we're looking good. And then if that's the case, then we break it down. Then we can follow difference of squares. I'm so excited to do the math. I don't want to write rules. Okay. So check it out. Are there two terms? Yes. Is there a greatest common factor? No. Okay. Are they subtracting? Yes. Are they both perfect squares? V to the second power? Yep, perfect square. 16? Yep, perfect square. If you're not sure what your perfect squares are, here's just, we're doing notes in the first box, I guess. Here's a list of them. It's going to be all the numbers times themselves. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, 64, 81, 100, and then 121 and 144. So there's all the way through 12. If you really want to see them, do a Google search, all the perfect squares, right? So this is 1 times itself, 2 times itself, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if my number here is one of these, that's a good indication that it's a perfect square. So to go with the example that we had on top here, v squared is really like v to the second power, and 16 is really 4 to the second power, right? Means the same thing. So 4 to the second power is 16. So when we have that, we have, and I have notes to kind of work around, the inside of each and then we just set that one is plus and one is minus, and it doesn't matter which one. And that's it. That's difference of squares. So doesn't matter if you do minus and then plus. You do want to double check to make sure that there's no more factoring that could take place, or like sometimes there's another difference of squares hidden in there. Here's another way that I think about it. Okay, are there two terms? Yes. Are they subtracting? Yes. Is there a greatest common factor? No. So that's fine. Do I have perfect squares? Yep. Yep. Okay. So what's the square root of m squared? Is m. And the square root of 9 is 3. And then I just say that one of them is positive and I need one that's subtracting. If you want to see how this works, watch. I'm going to expand this one out. M times m, m squared, m times negative 3, negative 3m. 3 times m, positive 3m. 3 times negative 3, negative 9. I go through and combine all these together. I get m squared. These cancel each other out, so minus 9, m squared minus 9. That's my perfect squares. So there's another way to think about it. I'm going to show you that again here. So I think really I should look for a GCF at first. I should have these flipped, but you know, I'm a disaster. So there you go. Square root of 4, 2. Square root of n squared, n. Square root of 1, 1. Okay, so I have one set that's going to be plus and one set that's going to be minus. Done. Difference of squares. Here's another one. Is there a greatest common factor? So can I factor out anything? Can 9 and 25 be divided by the same number? No. Okay, so watch how I do it again. Square root of 9 is 3. Square root of a squared is a. Square root of 25 is 5. I need one set that's plus. I need one set that's minus. So that's how I like to do difference of squares. I will show you something though, and it goes back to this. We might agree that these actually made, I just crossed them straight out, but these actually made 0m. So if you like the filling out the, actually that's not a good example. Too bad. Okay. It really only works with one kind. So I'm not going to go there anyways. Not for now. If you want to know what I was going to say, you can ask me later. Okay. Difference of squares, nothing, no greatest common factors. Square root of 16 is 4. Square root of b squared is b. Square root of 81 is 9. And I need one that's plus and one that's minus. Beautiful, right? Okay. Is there a greatest common factor? No. Are they both perfect squares? Yes. Yes. Are they subtracting? No. This is not factorable. Or it's actually in like simplest form. I don't know actually what I write is the answer here. We can't break this down. It's not factorable because of this plus. There's no two groups that multiplied to make that. That's just in simplest form. That's the answer. All right. So check this one out. This one's fun. Difference of squares, perfect squares are subtracting, no greatest common factor. Square root of 16 is 4. Square root of y squared, or of y to the fourth is y squared. Square root of 81 is 9. I have one set that's plus. I have one set that's minus. 4y squared minus 9. Here's the deal though. 4y squared minus 9 is another set of difference of squares. This one's not because plus. That's no good. But this one, 4 is a perfect square, y squared is a perfect square, and 9 is a perfect square. So I need to break this into two sets here. Plus, I can't remember that one that I already had. Oh my gosh, crazy? Maybe. That's our answer here. All right, one more example to show you all. Here we go. Sometimes we have squareds on both, and that's fine. Anything I can factor out? No. Is it subtracting? Yes. So square root of 9 is 3. Square root of x squared is x. Square root of 49 is 7. Square root of y squared is y. And I need two sets of them. There you go. Okay, I hope this helped you understand difference of squares. We'll get to practice this more in class together.